welcome to my YouTube channel. Today we will start with the next part of linear differential equation with variable coefficient, that is known as our Legendre linear differential equation. In our last video, we have done Cauchy's linear differential equation, that is also part of differential equation with variable coefficient. Now we are doing Legendre's linear differential equation, that is also part of differential equation with variable coefficient. First of all, we will see what the type of equation is. In this type of equation, we will write it down P naught a plus b x raised to power n. In Cauchy, what is it? It is x raised to power n. But in this case, we have a constant also, that is a plus bx raised to power n. Again, nth time derivative. Then n minus 1 and n minus 1th time derivative up to so on p and y. So what we can say here, p naught, p1, p2, these all are known as constant, where qx is a function of x. This is basically is known as Legendre's linear differential equation. So now always remember one thing, the power of the a plus bx is same as the derivative. If it is nth time derivative, the power of that variable is also n. If it is n minus 1 time derivative, its power of variable is also n minus 1. Now in this video we will see that how can we find a solution, what is the working method behind it. So before starting, first of all I want to write it down the equation. What is the equation? That is P naught a plus bx raised to power n dny by dx raised to power n plus p1a plus bx raised to power n minus 1 dn minus 1y by dx n minus 1 upon, then we will write down p and y equal to px. First of all, I would like to write down this equation in terms of symbolic form. So what is in symbolic form? If we have to write down in symbolic form, we know that we will write down dy by dx equal to d, and we know if it is d square y by dx square, it is, can we write down d square y. Generally, I want to say that d can be taken as d by dy derivative, then d square can be taken as d square by dy square. Similarly, if I want to write down d raised to power n, it can be replaced by d raised to power n by dx raised to power n. Here is a mistake, here is x, sorry for that. Now we will write down in symbolic form. So simply what we have to do, we have to replace with d raised to power n. We have to replace this with d raised to power n minus 1. So now see, if I want to write down this equation in symbolic form, firstly, how can I write it down? P naught, this would be a plus bx raised to power n d raised to power n p1a plus bx raised to power n minus 1 dn minus 1. Similarly, we will write down p2a plus bx raised to power n minus 2, then dn minus 2, up to so on. Here is a pn, and by outside it is qx. So now first of all, if we have to solve these type of equation, if we want to know what is working method, so in this case we will go with step 1. So what does step 1 says, that we will always put a plus bx as e raised to power z, and we will put z is equals to log of a plus bx, and a plus bx always greater than 0, as we know that we can find log of positive values only. After this, what we will do in a step 2, so remember in a step 2 we will replace d by dx, that would be theta. As we know that we will take d by dx as the d, but in just see, I told you what is the capital D, it is d by dx, but after this substitution we will replace d by dx, that is a theta. So again, if I want to replace a plus bx d, it can be changed b theta. We have to take the coefficient of x with theta. Similarly, if I want to write it down a plus bx squared, then d squared, I will write down b squared, that is theta theta minus 1. up to so on. If I want to write it down, a plus b x raised to power n d raised to power n, how can we replace it? B raised to power n theta, theta minus 1, theta minus 2, up to so on. The last value is theta, theta minus 1, then theta, sorry, n minus 1. Here the last value we will take here, that is theta, theta minus 1, theta minus 2, and here last would be theta minus n minus 1. So it could be replaced. After replacing it, then our step number 3. What is in the step number 3? In a step number 3, we will put all these values in our equation. Now like P naught, B, and theta, theta minus 1, because there is d raised to power n, it is theta minus n minus 1. Then plus P1, B raised to power n minus 1, again theta, theta minus 1. Up to so on, again you will get theta n minus 2. Then the Pn y equal to, again here x is replaced by e raised to power z minus a divided by b. You have to replace x in each and every here. After this, always remember this is a linear equation with constant coefficients. Now, in the last statement, we have y and x. In this statement, our equation is changed from y to y and z. Y, we can say it is y in terms of z. So now in this case, we will solve our equation y in terms of z. After solving our equation, there is a step number 4. In a step number 4, what we will do, that we will again substitute z is equals to log of a plus bx, and then we will get a required solution. Now in the next video, we will do a question based on the same method. So till then, thank you.